Hi there guys, and welcome to video number 130. This video is on proportion, and they are harder direct or inverse proportion questions. The keywords I've got for you are proportion, direct and inverse. I'll explain them in another video, but when something's directly proportional, one thing goes up, so does the other thing. And if something's inversely proportional, one thing goes up and the other thing goes down. All right, we're comparing two things in each case. Now, this is another example of where the unitary method comes in very handy, but these questions require even more careful consideration than the other ones do. In each case, you will need to divide and multiply in every question that you do, but there'll be three things that you need to consider. You've got to work on only changing one thing at a time using two of the three things, and multiply or divide to find one, and then multiply or divide for all. Then do that again. Right, and it's really challenging stuff. These sorts of questions really do my head in. Right, and you might be surprised to know or learn, or might not be, depending upon how you've seen my videos so far, that I'm not mathematically minded, not naturally gifted with maths. I have to work quite hard at being decent at maths and understand it. All right, which is why I'm making these videos for people that who are in the same boat as me, that can do maths but just weren't sure that they could do it because they weren't naturally gifted at it. So these ones, I think, if you're naturally mathematically minded, they'll be easy for you to understand, right? And you'll be looking at me going, "Why are you making it so complicated?" But for me, these are the ways that make this make sense. Okay, so in the first question, we've got a machine fills 2,000 bottles in 5 hours. Right, that's one machine. How long will it take three machines to fill 18,000 bottles? Right, so the three things we've got going on: the machines, the bottles, and the hours. Right, it doesn't matter what way round you write those things. Right, so we've got one machine, 2,000 bottles, and 5 hours. Right, that's how I'm writing those. We want to know how long it takes three machines to fill 18,000 bottles. So if we take the 1 and turn it into 3, right, how many bottles can 3 do in 5 hours? Let's leave the hours the same. All right, so we're leaving one of the things the same at the moment, and we'll see how many bottles that 3 can do in 5 hours. Well, that means that they can do 3 times more the amount, doesn't it? Obviously, there are 2 more machines, so therefore there's going to be 2 more lots of 2,000. Right, so 3 lots of 2,000 in total is going to be 6,000. All right, so the 3 machines can do 6,000 bottles in 5 hours. So we multiplied by 3 there, right? And that was just this one and this one. We ignored this. We didn't do anything with this. The hours stayed the same. All right. Ultimately, we want to know how many they can do, or how long it's going to take them to do 18,000 bottles, right? So we're going to change the 6,000 to 18,000. All right, and I think I put an extra 0 on that I didn't need to there. Yes, I did. And that is a number that we can, or 6,000 is a number that we can multiply by 3 again, right, to make 18,000. So we're just going to multiply this by nothing. We're going to leave that the same, 3 machines, right? And we're going to multiply this by 3. All right, we wanted that to stay the same. Yeah. So what we do there is if we multiply by 3, we get 15. Okay. So it is going to take those 3 machines 15 hours to fill 18,000 bottles. All right, I hope that makes sense. I think it's a pretty tricky question, right? But they do get trickier than that, right? And this is the other 2 that I provided for you for this. So the second question. Second question says that 5 machines can print onto 1,000 DVDs in 6 hours. How long will it take for 4 machines to print onto 3,000? So the 3 things that we've got here are the machines, the DVDs, and the hours. All right, the number of DVDs and the hours it takes. So machines, that's an M, DVDs, and hours. All right, let's just get rid of some of the things that I didn't really mean to write down there. I'm not really writing them as ratios, I guess. So machines is 5, and then 1,000, and then 6 hours. That's the information from the question. We need to get this number to be a 4 and this number to be 3,000, and then we're going to find out the number of hours it takes, right? So first of all, I'm going to work out 1. All right, so let's work out how long it's going to take one machine to do some DVDs. Let's keep the number of DVDs the same. So 1,000 DVDs and that's going to be a lot longer, right? So 5 machines can do 1,000 in 6 hours. 1 machine can do 1,000 in 6 times by 5 hours, right? Inverse proportion question going on there, isn't there? So we're going to multiply those numbers together. We'll get 30, right? So 30 hours to do 1,000 DVDs. Then we're going to look at changing something else, right? And that's going to be turning that into 4 machines now. So let's turn that into 4 machines and how long they would take to do 1,000, right? So what we can do with the 30 is we can divide that by 4, because that's going to turn that then into, because it's going to be 4 a quarter of the time effectively that it takes. So a quarter of 30, half it and half it again. That's going to be 7.5 hours, right? So they take 7.5 hours to do 1,000, right? So 4 machines, keep that the same. We want 3,000 going on, right? So we're going to have to multiply, because this one here, going to multiply by 3. I'm going to multiply this by 3. So 7 times by 3 is 21, and half times by 3 is 1.5. So 22.5 hours. It'd be the answer to that question. All right, 22.5 hours. All right, pretty tricky, but probably not as tricky as the third one. All right, dreading this one. All right, I hate doing these questions, but I'm doing it for you anyway. So in the third question, we've got 15 machines work at the same rate. Together, the 15 machines can complete an order in 8 hours. 3 of the machines break down after working for 6 hours. The other machines carry on working until the order is complete. In total, how many hours does each of the other machines work? Right, so this question. We've got some of the job completed by the 15 machines. So let's think of how much, or there's going to be some of the job that's been completed. It's going to be 6 out of the 8 hours has been completed by all 15 machines. Let's write down the 3 things that we've got. We've got the machines. We've got the, what have we got? The job. Let's call it the job. And we've got the hours it takes to do the job. So the machine's 15. The job is 1 whole job. And the hours is 8. That would be 1 whole job. 15 machines, 1 whole job, 8 hours. Right. Picking those out from the question. Now, we need to work out how long it's going to take 1 machine to do the job. So 15 times 8. So 1 whole job. 15 times 8 is 120, I think. Yes, it's 120. So 120 hours is 1 machine, right? Now 3 of them break down, right? So let's work out how long it would take 12 machines, because we'd only have 12 machines left. So 12 machines, that's a nice number. For 1 whole job, keeps disappearing, which is annoying. 12 machines, 1 whole job would take 10 hours, right? Because we just divide this 120 by 12. And that is something that we needed, but we're not quite there yet, because we want to know how long it's going to take 12 machines to do a quarter of a job. All right, that's how I'm thinking of this question, because there's a quarter of the job left. So I'm going to write this down: 3/4 of the job complete. That's what I kind of figured out at the beginning, right? Because they'd done 6 hours of the 8-hour job, right? So 3/4 of the job is complete. 1/4 of the job is left to do, right? So we need to know how long it's going to take those 12 machines to do a quarter of a job. So 12 machines, that's going to be divided by 4 to get a quarter, right? So that's going to be divided by 4, and that's going to be 2.5 hours, right? So 12 machines would have to work for 2.5 hours extra from the 6 hours. So that's going to be 6 hours plus the 2.5 hours, which equals the 8.5 hours in total. So they'd be working an extra 30 minutes each to get that job done. Yeah, that's it. That is the answer to the question. But it's really tricky, all right? I understand how tricky that is, but I think it's worth seeing a video where there's those 3 things that are going on, right? Work on two things, leave one of those things as it is in each case, and then you're going to get there. There's not one correct way of doing these problems. You might come up with a better way. If you do come up with a better way, please let me know. Show me in the comments section. Post a video, post a reactionary video to this one, and tell me that I'm spouting nonsense and these can be done much easier. But this is the sorts of ways that I look at these problems. All right. Please click the link in the description and practice. Take care of yourselves. Look after one another. And please continue to watch my videos. Thank you so much. Take care. Bye bye.